Hey everybody, my name is Steven. I am a project manager with Green Info Network. We're a nonprofit consulting shop based out of Oakland, but we have remote staff around the country, and we focus on data and maps for the public good. I'm also the Geospatial Interest Group Coordinator for the Data Visualization Society, and I'm here with Maryanne Wachter today to talk about one of the cool projects that she recently shared in the mapping channel. So we'll let her get her screen up so that she can talk about some of the cool work she did and give us some of her background to where she's coming from and why she was interested in making this type of thing.
Yeah, so I'm Maryanne Wachter. I'm currently a software engineer at LADBS, and I'm formerly a structural engineer. I used to work on buildings and bridges, and one of the sort of things I've always been interested in is looking at the structural engineer's impact on society. And one of the easiest ways to do that, since I live outside of Los Angeles, is actually looking at some of the soft story retrofits of buildings around Los Angeles. And soft story retrofits have to do with basically earthquake improving buildings, in this case specifically apartment buildings and condo buildings. And this was something that was required by law since like 2016 is fixing all of these buildings in the area. So I gathered a bunch of data based on some articles from the LA Times where they'd identified these buildings back in 2016. And then I cleaned the data and also took a look at the current LA Open Data website, which has all of the building permits. So I was able to take like buildings that have been marked for being retrofitted and buildings that had been retrofitted and sort of like take a look at how much had actually been done and then bring it into this.
Awesome. So you were motivated by just getting this important information on a map so that people could see where in the city buildings needed to be made more earthquake resistant.
Yeah, that's right. And one of the more challenging aspects of this, and I think one of the things that people might not realize a lot of the time, is that there's a lot of uh, open data, but it doesn't necessarily have the information that you need to put it on a map. It doesn't have latitudes and longitudes. So actually a big part of this project was using the US Census geocoder, which is free, to actually take all of the addresses and then get a latitude and longitude from them. Since I was doing this for free and I didn't want to invest a lot of money into this project, I used, I think I lost about 5% of the actual buildings that have been marked, but for my purposes, that seemed like a reasonable amount. Um, but yeah, so I was able to basically match the data. I used Postgres and PostGIS to also take a look at the addresses and getting the points close to each other. I did a little bit with like trying to get the building footprints, but unfortunately, a lot of these points, when you zoom in onto the map, they're not actually on like the building outlines. They're right next to it, so it's hard to actually get an accurate overlay. But yeah, so a big part of this was data cleaning, and then the rest of it was figuring out like an open source map stack that I could use.
Yeah, tell us about that mapping component because you're using something that's becoming more popular in the mapping world for this particular project, which I think is innovative and worth getting into the details a little bit.
Yeah, so I did not want to have to run my own tile server. So I actually used Protomaps, which basically gives you a static file that you can put in your public folder, like if you're using Create React app, and then I used Map Libre to be able to basically use the dynamic querying to load all the tiles and also have all of my data loaded onto the tiles to begin with. So for basically getting, I had two tile sets. So the first one was just the base map. So I'm not using I'm not using anybody else's servers. I took basically OpenStreetMap files from GeoFabric, converted them with Planetiler, and then converted from because I needed that to get into PM tiles. And so then I just have a single PM tiles file, one of which is just all of the sort of base information, like all of the street names that you're seeing, and like the building outlines. And then there's a separate PM tiles file just for the all of the markers and the actual soft story data that like all of the database entries that I then added to it. So this is additional context.
Wow, that's really interesting. So even the point files is a PM tile file. That's not like a tabular file, which is loaded by the web browser.
Yeah, for this case, I've done a couple of maps this way now. When I originally did this, I was loading the data as just like a JSON file in the browser because it wasn't that big. But
Hmm.
I've been experimenting with other maps and just to like reduce how much is getting loaded. It was easier to basically convert everything into different tile files that are then loaded separately.
Nice. Yeah, so taking data and getting it ready for a map involves a lot of other skills that might be sort of new and outside of the realm of like geocoding and converting between formats and getting data sources for maps. So yeah, there's a lot to making maps, that's for sure.
Yeah.
So the
Um,
tool itself, tell us a little bit more. You've been demoing the functionality a little bit as you talked, but tell us what the map is doing and what it's showing at different zoom levels.
yeah, so when you first load it up, I actually, this is heavily drawing from one of the examples that MapLibre has. But yeah, the idea is that it's aggregating data when you're all the way zoomed out because it would be visually like difficult to sort of understand what's going on if you've just got like a million dots. I did try a couple of ways of like aggregating based on the different types, but so overall what it's showing is basically a pie chart where this is the number of buildings or entries for the entire pie chart. And then the blue means that it has been tagged as being retrofitted or there's a retrofit in progress. The red means that it was in that original data set, but is not currently in the permitting database. And then yellow is actually something interesting where there were a number of buildings that were originally marked as needing to be retrofitted, but then there was some kind of investigation and then they ultimately decided that they didn't need to be retrofitted. So what is interesting, like, so as you zoom in, we break out the circles into smaller areas, and eventually you get to a zoom level where it will show you all of the markers. And like once you have a marker, you can actually click on it and see what exactly the work description was. Because this is how I filtered on the original data set to be like, if it has verify in it, then that probably means that this wasn't actually retrofitted. It was just marked as not as being investigated. So these some of these fields, there are a lot of fields that I didn't include because they weren't necessarily relevant. I thought it was interesting to include like the contractor's name who did the work. Sometimes it's some very generic, like the owner builder, but in other cases, you'll actually get, I'm getting a lot of owner builders on this part of the map. You can actually see who's doing the vast majority of these sort of retrofits, and there might be like thousands done by a single company, which is pretty interesting.
Nice. So what's special about this map that we're looking at is that you're using static files for everything. So you have static background map and you have static pins so that the infrastructure needed is a lot lighter. And by having static files, it's also much faster to interact with these thousands and thousands of points on a map and even get all this detail. So I think that's really cool.
Yeah, it was so I worked a bit with Brandon Liu, who is the creator of Protomaps, just to understand like how this would work. And originally, Protomap's big selling point is that, oh, you can just have something like S3 serve your map tiles. But what I told him was like, I don't even want to do that. I have enough space on a server, so can I just store this somewhere that like I can access it on my server? And yeah, and that's how this is working. Is just that I think the overall tile file for the city of Los Angeles with all of the detail that I have is about 400 megabytes, which that's incrementally loaded. It's not loaded, during when you first spin up the website. And this also means that I don't have any database attached to this. It's just all static files. I basically copied the results of running Vite build onto my server.
That's awesome. So this stack here is helpful if somebody wants to visualize big data quickly and easily on a map and have very low costs associated with it, even if you have large file sizes like a 400 megabyte file, because you're only loading what's in your view. And so there's not 400 megabytes worth of points in front of us right now. So that's really cool. That's a great way to use maps in an open source way, in a sort of self-serving way, without having to use any of the big players like Esri or Mapbox to put your data out there on the web.
Yeah, that's right. I this is more of a hobby exploration for me. It's something I've always wanted to do, but I haven't wanted to invest a lot of money. I did invest a fair amount of time in figuring out how to do this. But like the steps that I have followed for this now means that it's really easy for me to, once I have the data, throw up another map. Like I did a different map looking at NYC building complaints, and this one took me a couple of hours to spin up an entirely new one. And it's also the same idea. It's posted on my server.
Nice. Awesome. Well, thank you so much for taking the time to talk to us today. You've got a great blog post here going into some details of how you did your work. Is there anything else that you want to tell folks about yourself before we go?
Yeah, I mean, you can find me. So I like to write about the sort of process of some of these like side projects that I do. Mapping has been sort of an interest for me for quite a while, and this project gave me an opportunity to really dig into how it all works. You can find me on Mastodon, recurse.social / at MCLARE mclare. And I'm also on Twitter at ENG_mclare. Yeah.
Awesome. Well, thanks again for showing us this work. And if anyone has any questions, you could find Maryanne on DataViz Society Slack and on socials. All right, everybody have a great day.